Hello friends, welcome to today's lecture on saline and alkaline soil. As we have started with water logging, we have seen what are the issues associated with water logging and what are the ill effects and what are the probable remedial measures or preventive measures of for the water logging. So out of n number of issues, waterlogging increases the salinity of soil. So today we will deal with the saline and alkaline type of soil and we will see how to overcome these issues. So let us start. The presence of an excess sodium salts and the predominance of sodium in the exchangeable complex are divided into two main groups. First is the saline soils and second one is alkaline soils. Saline soils contains an excess of sodium salts, but its colloidal material is not yet sodiumized. Second is the alkali soils. In the case of alkali soils, the exchange complex contains appreciable quantities of exchangeable sodium. Such soils may or may not contain excess salts. Alkali soils may be divided into following groups. So basically there are two broad types, saline soils and alkali soils. So alkali soils will have following subtypes. First is the saline alkali soils. When they contain soluble salts in excess, they are known as saline alkali soils. And second is non-saline alkali soils, which are basically called as alkali soils. When they do not contain any soluble salts, they are called as non-saline alkali soils. Then degraded alkali soils. Under certain circumstances, the clay complex of some alkali soils is broken down to give rise to the degraded alkali soils. Then the characteristics of saline and alkaline soils. So first of all, we will see the characteristics of saline soils. When the soil contains excess of sodium salts and clay complex still contains exchangeable calcium, the soil is known as a saline soil. The saline soil is one which has excess of sodium salt. Okay, it is also known as white alkali or brown alkali soil. The process of accumulation of salts leading to the formation of soils is known as salinization. Saline soils contains usually chloride, sulfate, bicarbonates and sometimes nitrates of sodium. The presence of chloride and sulfate of sodium gives white color on the soil surface. When the nitrates are in excess, they give a brown color to the soil. Exchangeable sodium percentage, that is ESP, is very low, being less than 15% of the total cation exchange capacity CEC. As a consequence of low ESP, generally the pH value of this type of saline soil varies between 7.5 to 8.5. Total soluble salt content is more than 0.1%. It is high enough to interfere with normal growth of most of the plant species. So it is important, though the salt content is very few, 0.1%, then also it is high enough to interfere with the normal growth of the plant species. Then electrical conductivity EC of solution extract saturated soil is 4 or more millimoles per centimeter. Saline soils remain in flocculated condition, granulated. It is permeable to water and air. Saline soils usually have a surface crust of white salts, especially in the season when the net movement of soil moisture is upward. Salts dissolved in soil water move up to the surface when they are left as a crust when the water evaporates. So you will see the whitish kind of surface in case of saline soils. Then alkaline soils or sodic soil. Non-saline alkali soil. It is the first type, non-saline alkali soils. The characteristic features are the presence of the colloidal complex that is saturated with exchangeable sodium and the absence of appreciable quantities of soluble salts. Soluble salts are not present in so much quantity in these types of soils. These soils are often called as black alkali soils because they are black owing to the effect of the high sodium content, which causes the dispersion of the organic matter. These soils are also called typical Usar soils. Usar means barren. These soil contains sodium carbonates in abundance. Exchangeable sodium percentage is greater in these soils, which is more than 15%. Consequently, pH ranges from 8.5 to 10, which is strongly alkaline. Total soluble salt sodium content is less than 0.15. Electrical conductivity EC is usually less than 4 millimoles per centimeter. Colloidal complex is deflocculated and dispersed. The clay swells and chokes the soil pores. Hence, permeability of water and air in these types of soil is very poor, or infiltration and aeration is low. The presence of free sodium carbonate has a toxic effect on the plant roots. Also, high pH and poor physical condition of the soil adversely affects the plant growths. These are the factors to remember. The presence of free sodium carbonate has a high toxic effect on the plant roots. Also, the high pH and poor physical condition of the soil adversely affect the plant growth. Also, this soil is doesn't allow the infiltration and aeration is also low. The sodium carbonate absorbs organic matter, so there is great depletion of organic matter. Therefore, the soil are almost barren, which is called as usar. Then second type is saline alkaline soil, saline alkali soil. These soils are both saline and alkali. There can be all stages in transition with varying degree of dominance of salt content and pH. According to movement of soluble salts, formation of saline alkali and non-saline alkali soil depends. Soil contains sodium clay as well as excess sodium soluble salts. If the soluble sodium salts are not leached out due to the insufficiency of rainwater, they remain in the soil. The soil thus contains sodium clay and excess soluble salts in solution. Such soils are known as saline alkali soils. They are thus developed as a result of the combined process of salinization as well as alkalization. In spite of the presence of sodium clay, the soil remains friable and possesses aggregate flocculated. This is because the presence of sodium salts does not allow the sodium clay to get dispersed and keeps it flocculated. Thus, this soil behaves more or less like saline soils. If due to much water soluble salts are leached down and soil contains sodium clay only, thus this soil behaves more or less as non-saline alkali soil. Therefore, the soil structure becomes unfavorable for the entry and movement of air and water. This will also not allow or facilitate air and water movement, which is required for the plant growth. Then formation of saline and alkaline soil, how these are formed. Origin or development of saline and alkaline soil depends upon the following factors. First is arid or and semi-arid climate. Alkaline soils are those that have an alkaline reaction or whose pH is greater than 7. Alkalinity is due to sodium salts in soil solution or the presence of sodium clay or both. They are formed in they are formed in arid and semi-arid regions which have very low rainfall and high evaporation. The low rainfall in these regions is not sufficient to leach out the soluble products of the weathering, and hence the salts accumulate in the soil. During rain, the salts dissolve in the rainwater and move down in the lower layers. However, due to the limited rainfall, the downward movement is restricted to a short distance only. In dry weather, the salts move up with the water and are brought up to the surface where they are deposited as water evaporates. So ultimately, the soil surface will be adhered by the salts after the deposition of these salts. Then second cause is what? Poor drainage of the soil. During the periods of high rainfall, the salts are leached from the upper layer, and if the drainage is impeded, they accumulate in the lower layer. When water evaporates, the salt is left in the soil. Such soils are generally developed in low-lying areas or in basin-shaped areas. Next is due to high water table. The groundwaters of arid regions usually contain considerable quantities of soluble salts. If the water table is high, large amounts of water move to the surface by capillary action and the evaporated, leaving soluble salts on the surface. Next cause is overflow of seawater over lands. Low-lying areas near the sea which get seawater during tides, salt water accumulates and enrich the soils with salts. Introduction of irrigation water. The groundwater of arid regions are generally saline in nature. With injudicious irrigation, the percolating water may get linked with the saline groundwater. If there is no what you can say proper planning of irrigation water, then the percolating water will contaminate this irrigation water, and further the saline groundwater will come in contact with the irrigation water. During dry weather, the soluble salts of the groundwater may thus get carried to the surface and increase in salinity of the land. The irrigation water may be itself rich in soluble salts and add to the salinity of these kind of soils. Salts blown by the wind. In arid regions near the sea, lot of salt is blown by wind year after year and get deposited on the lands. Due to low rainfall, they are not washed back to the sea and thus add salinity to the land. The salinity of Rajasthan has developed to a great extent due to this reason. So all these are the causes which causes salinity to the soil, alkalinity to the soil. So we will see the reclamation of the saline and alkaline soil in next part. So if you are having any doubt so far, you can ask me on my email address dnpaitankarce@sanjeevani.org.in. Thank you for listening. Happy learning.